Hello everyone and welcome to a new topic and discussion, which is spatial database systems and their types. So, this would be in two parts minimum. It is a big topic, as you know that database management itself is has become nowadays big subject. But we will be mainly focusing on that part of database management systems which is related directly with GIS, not a generic database management system. Otherwise, it would be a very long, completely separate discussion also. As you know that if we compare with simple file systems which generally we follow in our computers, laptop or desktop, we go for file systems. But if we organize the data in databases, then we can get lot of advantages. All in GIS, as you know that two types of data, one is the spatial data, another one is the non-spatial data. So, non-spatial data is organized in a database, and overall we say spatial database. So, spatial database, when we mention, it means that we are having not only spatial information like point, line, polygon, raster, tin, etc., but we are also having attribute information organized in our database. So, the conventional database management systems, though they are in the background for us, but the major difference is that we are having good connection or dynamic linkage between the conventional database systems and spatial information also. And through, obviously this is done through your geographic coordinates, and that allows us to handle this thing. So, in this discussion we are going to have very briefly what is a database and how it is designed, why it is important for the GIS users, and how modern databases evolved from files to file systems, and then how about flaws in file systems, means lacunas, and what a database management system, and how it fits into our GIS database system, and different types of databases models which exist so far. And mainly we will discuss, again as I am repeating, related with GIS, especially like relational database management system or RDBMS is the most common database system which has been implemented in GIS and most useful also. But databases like network and others are also being used nowadays extensively. So, when I was discussing the network analysis, at that time I mentioned that network database are having linkage with for network analysis. So, if you are having your data in that structure, then network analysis can be performed in a much easier manner. Anyway, so first, as you know, the data versus information, and when some might be wondering what is basically data. So, data are the raw facts basically, and these data we are organized into a computer or in a database and convert that data or raw facts into information. And GIS obviously goes one step ahead. Through GIS analysis, this information can be converted to knowledge. So, GIS is capable of handling not only raw facts, that is data, it also allows us to convert that raw facts or data into information and finally into knowledge. What is there, how it is there, how it will become after such changes, and that basically is nothing but the knowledge. And also through the prediction or modeling, we get lot of insight about the data. So, basically as you know that information is generated through data. So, it is a building blocks of information, and information is produced by processing data that can be done easily in if it is attribute data, it can be done very easily in a conventional database. But if it is a GIS data or spatial data, then it can be only done on a GIS platform. And when we process the data, then these raw facts can reveal quite good information. And of course, when we do this processing in GIS, we can convert finally data into knowledge. So, good, timely and relevant information are the key for decision making. So, if you are having good means here, the good and timely means you are having not only the quality of the data, but very updated information, updated data and relevant data, and that will allow us to process it as quickly as possible, convert to information, convert to knowledge, and when we present these scenarios to decision makers, they can make quick decisions. So, good decision making as you know is the key to organizational survival or success, and everyone would like to have a very nice database management system in their organization, so that whenever they want that information, that data, immediately they get it in a organized fashion, and also this has to be updated. The timely and quality data is most important in this. So, basically in what we do in database management is, database is shared integrated computer structure which houses the end user data, which also is a metadata, that is the data about the data, that means the information about the data is called metadata. Even in case of satellite images, generally you may find when you download a free satellite image, you will find a file which is .met. That does not mean it is having meteorological data, that means it is having the metadata, the information about the that particular satellite image, when it was acquired, which was the satellite, which was the sensor, who has done what kind of processing so far. All that information is recorded in the metadata, and it is a very good practice of good organizations to record everything about the data, who has generated that data, how much processing has been done, when it was generated. So, all that information can go as metadata. Now, in this database management system, what we do, we manages the database structure, how, because there are different structure, different models are there. So, this is first task which is done in database management system. Also, it is a controls access to data, who will have the access, how much he will have the access, or when he will have the access. All that can be controlled by the administrator of the database management system. Also, it should allow us or users to query in a very simple manner. I want to access the data to certain purposes. So, I should be allowed to get certain information from that database only through this query. So, this query language has to be also very simple and should be allowed also. Now, when we discuss the importance of database, that database management system makes data management more efficient and effective. Also, query language allows quick answers to ad hoc queries. Suddenly, you are having a question, you just raise that question through a easy syntax and you get the answer from the database, if it is having that information, obviously. And it provides the better access to more and better managed data. Promotes integrated view of organization's operations, that how the organization is working, and how it has been integrated within that. What it means basically, that a organization may be having good databases, but lying at different places for different purposes, and there is no integration or there is no talking between two databases, and therefore the query, if I want, I cannot have a integrated or nested query implying two different databases within that same organization of two different divisions or sections. So, integrated view is also, or integrated way, it is also sometimes important. And if you are having a good database, it reduces the probability of inconsistent data. There will be a discussion also islands of data. That means the data is lying, but it is inaccessible or it is not getting updated, inconsistent, and then it becomes a confusion and maybe useless information, and unnecessary it will occupy space in our computer systems. Now, when we discuss like a database management system, then what we find that there will be always end users, and maybe at different ends, and then they will have some way to interact with the database management system. So, application request, and then there is a flow of the data in two directions. The same way, then this database management system will allow for the organizers, and as per the chosen database structure, of course it will have metadata, the customers are being handled, the invoices might, depending on the organization, this example is from the sales organization, and then products. So, a company which is having, say, online company which is supplying certain items. So, likewise, and again end user data is here. So, that is being maintained, is a typical database management interaction which we see here. I will give you a example at this stage and may discuss little later further. Many of us, or let me say that lakhs of people are interacting with the IRCTC database system or IRCTC portal for booking our seat in a train on a particular day, on a particular class. And you can think that how complicated that software is or that portal is. There are more than 6,000 trains, may not be currently during corona period, but otherwise in normal conditions more than 6,000 passenger trains are running 24 hours, having different classes, different categories, and more than 2 crore people are travelling at a time in these trains. So, you can imagine that lakhs of people are booked or logged in at the same time to book their seats on a train. So, that is also a very good example of a good design of a database. Though directly it is not related with GIS in that sense, because geographic information is not handled in that IRCT, but from database design and management, it is a very good product, a very good example of the nice, because information is being updated, any change happens, it is implemented, any category is, any new train is introduced, that is implemented. So, it is a very good example of a good database system. Now, that is why the good design is the key, starting point has to be very good. If poorly designed database is there, then you will have lot of data redundancy. Data redundancy means data is lying in database, but it is not accessible to anyone, and data is just occupying your storage space, and it is very bad example of poor design. Poor design also generate errors, sometimes leading to bad decisions. You think that if IRCTC portal or software database is poorly designed or having some errors, then that can create havoc in railway system, but no. And if they find any error, obviously they go and immediately correct it. Otherwise, we will be booking a wrong seat in a wrong train on wrong date, and that would be a disaster in the country, because remember 2 crore people travelling all the time on 6,000 trains all over the India. So, good designs is very much important. Now, what are the practical approaches? Focuses on the principles and concept of database design, that is the first task is done. Then importance of logical design, design has to be very logical, how data will flow. Before that, we will also discuss about the historical roots of the data. We started with the file system when we got introduced to computers, and slowly we have started moving now on DBMS or database management system. So, first application focused on the clerical task, simple task which a clerk used to do in an office. These were thought that let the computer do it. A request for information quickly forwarded, and that was that if somebody has asked information, let's share that information. So, basically we started with a file system which was developed to address the needs of like data organized according to expected use and data processing specialist computerized manual file systems. Now, this terminology which started with the file system still many terms continues in our database. So, it is necessary to know also. I have already mentioned raw data means raw facts, and field or a field or column in a spreadsheet kind of concept, that is the group of characters with specific meaning. That like if you see a table, then individual column becomes a field in database, but in display it is displayed as a table. So, field is important, and characteristics of the field are also important of the data. What type of data it is, and in GIS term what type of attribute it is having, and if it is numeric data, then what is the precision of the data, and so on. Because once the data has come there and you want to change anything in that field characteristics, you may have problem later on. So, it is always in a better design to think that what kind of data will be coming in that particular field, and accordingly the characteristics should be decided. And record are the row numbers basically. So, logically connected fields that describe a person, place or that. So, that is also a record, and overall this information is kept. So, collection of related records, that is in file. Now, these terms are still being used, though the file system GIS file system database is not used. Now, as you know, in simple files, lot of us uses the computers and laptops and other things, and many times we keep the data in simple file systems, and because they are not related to each other, and therefore sometimes searching even or making access to other or multiple files together becomes very difficult. So, some limited search can be made. So, if the same scenario, if I put about a organization which is involved in sales and business, then the sales department is having its own file system, and then you are having the personal department is having its own file system, and every information this is all lying in isolation. And of course, here the customer files are also there. So, sales department and customer everything is one, but the personal department is completely detached, means it is not having any connection. So, these two systems are lying completely in isolation, but in a typical database management system everything should become integrated. Now, what are the bad points of a file system? As you must have realized that in the file system requires extensive programming in third generation language to access the data, and even make a search or make a query. Of course, it is time consuming and also makes these ad hoc queries impossible. That if we are searching certain things, we may not get that information, though that information might be residing in some of the files which are lying in complete isolation. And if that is there, then these islands of informations becomes very common, and that means unnecessary occupancy on our storage because of file system. Now, this file system is also data dependent, and if any change occurs in the characteristics of data, that means it is also modifications are required in data access programs which are in the third generation. And also everything has to be told to the this program that what to do and how to do. And file systems make cumbersome from programming and data management views. So, file systems basically each file is lying in isolation, though maybe in different folders, but still it is not well organized database management system. Also, it is having a structural dependence, and modifications cannot be done. If changes in file system structure requires, modifications of related programs will immediately be required. Now, field definitions, that means the column definition or characteristics is also one can face lot of problems. Now, flexible record definition anticipates reporting requirements, and selection of proper field names important in file system. Attention to length of field names is again important, because later on you may change, but it may bring some errors also. So, before even bringing data into a particular field of our database, we must be careful about these characteristics, the length, the width, and what kind of data is going to come. And use of unique record identifier, that is very much required here. For each record there has to be a unit identifier. Now, when we go for file systems, the data redundancy is a very common thing, and sometimes different and conflicting versions of same data is there, and sometimes if we don't know, we don't have proper recording of metadata, then one may get confused that which is the latest and which is the oldest, and so on. And results of uncontrolled data redundancy, and data anomalies might be there, modifications are difficult, insertion or problems, deletion might be also problem, and data inconsistency might be there also with the file system, which brings the lack of data integrity. When we go for database management system, it consists of logically related data stored in a single repository, and that is the advantage, not in different files, and they are related with the logics and organized in a fashion that our access to the data or retrieval of information becomes much easier. If you recall the definition of GIS, it says that this data is coming from variety of sources, and it allows the retrieval, easy retrieval of the data. So, if it is organized in a proper database, well designed database management system, then only efficient retrieval is possible. Efficient storage and retrieval is possible, otherwise not. So, obviously database systems are advantageous over the file system management approach, and this will eliminate the inconsistency in the data. It will also eliminate the data anomalies, data dependency, structural dependency problems also, and it stores data, structures, relationships, and access paths. This access path is very, very important from the security point of the data, which we will discuss little later. So, if we in nutshell, if we discuss file system versus database, this is what in a database system we are having a centralized database management system here, and every inventory or related data is there in the database. Different departments may work independently, but they are all connected with one database management system. Whereas in case of file system, all people are working for the same organization, but their informations are independent to each other, and every information is lying in isolation, and they are not logically either related or connected, and therefore getting information from one department to another may be very, very difficult. But here all personnel, sales and accounting department can have, because their data is residing in the same database management system, and therefore access and controls becomes much easier. Now, if we go further to in that same database system environment, then we also have the procedures and standards. Nowadays, this is very important to talk about standards also of the database management system, because tomorrow somebody might be changing to some other database management system or allowing access to your data. So, if it is following certain standards, all these paths would be very clear, very easy to have access. Otherwise, you may say no, our format is different, your format is different, I am sorry, you cannot access our database. So, if standards are followed, then these problems will not come. And then there is a application programs which allows the end users to access the data. Programmers, they write, so this is one way information. The end users through application programs can access the data, DBMS. So, if I give the example of IRCTC or railway, we can put ourselves and end users through that interface program on net. When we log in, we go into this program like this, and then we start accessing the database management, which is very updated almost every second. So, we know in which train now how many seats in which particular class of that date are vacant. There are of course overall system administrator to control everything. There will be a database administrator which will be focusing mainly or managing the database. There will be a database designer, because time to very frequently they have to change something in the design or a tweak within this design, so that they get the they can accommodate new train, new class, new route, all kinds of things. So their designers are also involved, and of course then these procedures and standards, they are connected with the rights and enforces, these standards are enforces to data through data administrator. So likewise you are there, and one important thing is about of course the data is there, but important point about the backup, because such important system has to have a very good backup things in their system, and backup may not be at the same location. Backup may be at a remote location. In case of some accident or some fire in the data center, then the whole entire Indian railway system will collapse. So there has to be a frequent backup or live backup, continuous backup, and maybe at different location. So this is how it is followed in many large database systems. Now when we design the database, the concept either it is going to be used by single user or one user at a time, or maybe multiple user database, or millions of users at a time, like your IRSCTC. Again, are people going to use on desktop, work groups, enterprise, or even through mobiles? So that is another, the latest thing, that every such databases are being allowed to use through mobiles also, smart mobiles. So that way the database designers have to be should think at in the beginning nowadays, because that is the most common devices which is being used. And again they have to decide about the centralized or distributed systems. People talk about cloud and other systems, fantastic. Can we have a centralized system, or should we go for a distributed system? So there it has to be also weighted. And then who are going to use, what is the purpose or other things. And because the database type, system type will depend on all these parameters, and of course production or transactional, like banking, State Bank of India site, that database is a transactional, or some factory might be having, so it is production related. And decision support or data warehouses. Now whether my data is related or database management system is being designed for making good decisions, timely decisions, or is a data warehouse. So the type will depend on all these things. Now what basically different functions within the DBMS are? It maintains the dictionary management, data storage management, data transformation and presentation, security management. Nowadays it has become very, very important, because people are hacking these large systems differently, and sometimes they can create havoc. So the security management is also very, very important. Multi-user access control, how users will have access, that can be controlled. And of course this I have already mentioned, that backup and recovery management systems are very much required, data integrity management, and database language and application programming interface. So you might see that in every few years time, or almost every year, we are seeing some changes in IRCTC side. And then database communication interfaces, how it will and which kind of platforms and it will be used, which are going to be the interfaces or browsers, how it will be communicated, that has to be also thought, designed, and then finally checked. Now these, when we talk about the database models, it's a basically collection of logical constructs used to represent data structure and relationship within the database. Now these conceptual models in which a logical nature of data represented, and whereas in this implementation models which emphasizes on how the data are represented in database. Now the most common one which in GIS is related with is the relationships or relational database in conceptual model. So, we start thinking from that. Now, this relationship either one-to-one relation, or can be one-to-many relation, or can be many-to-many relation. So, three scenarios are possible: one-to-one, one-to-many and many-to-many. Now, in case of implementation database models, we can have hierarchical model, quite common in many organizations, network based, like if I have to do lot of analysis which requires network analysis, then network type of models, database model is most appropriate. And finally, of course, the relational database. I want to relate one database with another, and things have to be organized accordingly. So, implementational database models are hierarchical, network and relational. Now, in the second part of this discussion, we will go in details about these concepts with some examples also. So, with this I end this discussion. Thank you very much.